I'm Eric Harnes, so founder and the CEO of SixWind. SixWind is a gold member of the FD.io project. And clearly today I'm not going to talk deeply about technology, but more about why SixWind joined the project, which kind of application this nice, how this nice technologies can be used in some applications. So I've selected the NFV1 and the NFVI infrastructure. So I will talk about the requirements, the different solutions that may be available in the market, and also give you an example to show in a real case, which is basically a security gateway, how this kind of technology can be used. Okay. So let's start. So a quick introduction about SixWind for the people who may not know about the company. I'm not sure it's possible, but in any case. So SixWind is a French local company. So we are specialized in high performance networking software. So the company is based in France, western suburb of Paris. We have a subsidiary in the US, people in China, Korea, and Japan. And our primary business has been the infrastructure software for networking, basically how to develop a high-performance networking stack on standard servers. So we combine a certain level of software expertise with an historical experience in telecom, because we delivered our first software to 4G network equipment providers. And if you go in some countries over the world, your 4G traffic may probably come through a SixWind software. Our products are used for both network operators and OEMs. So we are a VC-backed company with a well-known investor. It's not the reason why we are here, by the way, but Cisco is an investor in the company. And as I mentioned just before, we joined FD.io as a gold member at the level of Huawei, which is pretty nice for SixWind, and just under Intel, Ericsson, and Cisco. But so we are obviously the smallest of the five. So we got a few awards, so as all good companies should have. So why we are in this business, as I mentioned just before, so we have, that's most of the deployment today, we have a high-performance specialized hardware, router, and all these things. And the idea is clearly, in fact, to deliver the right capabilities in terms of software on standard server. First of all, to reduce the capex of the equipment, and also, thanks to virtualization, if we bring this performance to virtual networking, of course, bring much more capability in terms of virtualizing the network, making them more adaptable with a fastest service creation. So a double cost saving on capex, and then in the second time on OPEX. Let us start about the NFV. So clearly, if we want to, especially in the NFV space where the VNFs are really bandwidth demanding, so clearly implementing standard networking functions on the servers leads to some performance challenges. There are, to make it short, at two levels. The first one is clearly at the hypervisor level. So now, in fact, the network goes beyond the server itself. It goes to the virtual machine. And so the function that can be first a virtual switch, but many more, has in fact to manage the traffic to be delivered to VMs and also between VMs on the server. And then, unfortunately, we have 10 gig, we have 40 gig. We have friends from Intel, Mellanox, and so on, providing already 100 gigs. So the problem is not going to be reduced in the coming years. This is the first one. Then at the apps level, so we have typical driver bottlenecks with Virtualization, and also what we see with a couple of VNF vendors. If you just take your software that has been designed for standard equipment to a multi-core based server, obviously you are not going to make the best use of your hardware. So it has to be redesigned, because generally the problem comes from the data plane. The data plane does not scale. So that's it. So there are, of course, a couple of solutions. So the first one is to use Linux. It's pretty easy. There are plenty of advantages with Linux, all virtual switching, networking features, heterogeneous NICs, and so on. The complete solution is supported in the well-known environment, either OpenStack, OpenDaylight, because it's the primary target for these systems. So that's nice. On the other side, the Linux networking performance stack doesn't scale at both virtual switch and application, guess communication bottlenecks. So this solution can be used in a standard data centers, cannot really be the one selected for high performance NFV. Of course, there are solutions. So the first one is a pretty straightforward solution, I would say. If there is a problem, just eliminate it, and then the problem will disappear. So we can cure the problem with SR-IOV, that basically bypass the hypervisor, so no problem at all. That's done. The cons are you lose the hypervisor features. You are hardware dependent, virtualization is broken, how you migrate your VNF. And of course, you only fix the performance at the hypervisor level. The performance problem remains at the application level. So, as you know, SixWind has been deeply involved from the very beginning in the DPDK project, and the DPDK is clearly the foundation of high-performance networking software, and I think it's well recognized now in the industry to preserve performance and the hardware compatibility. So what is DPDK? So I guess most of you are very familiar with DPDK. So it's a set of library drivers for high-performance packet processing in Linux user space. Low overhead, run-to-completion model, can be used in the hypervisor domain or in application. Built with open standard in mind, is compatible with all major hardware vendors. What it's not a networking stack. Otherwise, if it was, we should not talk about BPP today. And DPDK does not provide any functions such as layer 3, forwarding, IPsec, firewalling, and so on. So I've often the question, so SixWind, so what do you do above compared to DPDK? I'm saying, so DPDK is just a tool. Now you have the tool, you have just to develop the complete stack, okay? Just for people who don't know, but I'm not going to talk a lot about this. DPDK, so data plane libraries and optimized NICs driver in Linux user space, buffer management, queuing, packet flow classification, pool mode drivers, and so on. So the project, yes, clearly DPDK is, let's not be shy, is the most successful project, open source project in high performance networking today. So first of all, it's not the main reason, but it has been launched by SixWind in 2013 as a BSD license project. So initially developed for x86 CPUs and NICs, Intel NICs. So now, in fact, it's go much beyond, and it's clearly the open source framework for high performance networking now. So in terms of processors, so supported IBM Power, Mellanox TalGX, I forgot probably the Broadcom X NetLogic processor, and also ARM CPU. And regarding NICs, so I think almost all the NICs now have a DPDK driver, okay? So it's a vibrant community, so more than 3 million pages visited since the project launch, close to 40K visitors per month growing. And I would like also to thank the maintainer of the project, so Thomas, who is at the top level here, and Vincent also, who are a big contributor. SixWind is the second contributor to the project because Intel is the biggest. This said, what I want to say is we divide the number of contribution per employee. I guess SixWind is still ahead, okay? So, and the way to measure the success of an open source project is how it is used by other projects. And so I was at the Open Networking Summit 2 months ago, probably, in the Bay, and all the presentation, almost all the presentation just mentioned DPDK. And today there are more than 20 projects, open source projects using dpdk.org, OPNFV, OVS DPDK, FIDO VPP, RUMP, DPDK, NGINX, plus, of course, all the internal projects in different companies. So we can really say that it's a success, and it's also a recognition that VPP has, in fact, in a certain way, selected DPDK as its foundation. So, as I said just before, DPDK is just a tool. Now you have to develop the networking stack. So there are a couple on the market. The first one is OVS DPDK. The second one is 6WinGate, so it's our own software. And the next one coming is FD.io, and clearly 6Win want to be involved in this as a gold member in the project. And clearly we are thinking about supporting our own version of VPP, so which we call 6Win VPP. So let's do a comparison between all these three solutions, knowing that it's a snapshot. So what is true today is certainly won't be true tomorrow, because so I've heard that there are many, for instance, ongoing projects in VPP and FD.io. So if we compare, so let us take OVS as a reference, just to mention. So OVS is mainly for switching, available in all the Linux distribution, and the performance, as I explained before, are Linux-based or poor. And we have globally three solutions. I'm not going to enter the debate about performance, if VPP is better than OVS DPDK 6WinGate, so we can have a debate on this. But knowing I have only one column, I would say that all are pretty high performance. OVS DPDK is mainly for switching. VPP is today switching and routing. And 6Win switching, routing, and TCP. And I said just before, knowing that there is a TCP project in VPP, of course, it would change. In terms of management, Linux is managed, OVS is managed by Linux tools, OVS DPDK by a subset of them, and both are now, so OVS DPDK, if I'm right, has been recently introduced in all major commercial Linux distributions, so including Red Hat, Ubuntu, and so on. So 6WinGate is, as I will explain, that's probably one of the major differences between 6WinGate and the other solution is it is based on what we call the Linux synchronization. So it's not a standalone stack. It's a stack that uses the Linux, in fact, to be synchronized with. So it's one of the major differences between the different solutions. And so in terms of management and configuration, Linux plus 6WinGate is like Linux. Okay. The other ones are more separated standalone solution, and for which there we need some specific management tools. Let us talk about this. If you want to build an application with a control plane on top of a data plane application, so if we take, for instance, first 6WinGate, knowing it's synchronized with Linux, an application using a standard TCP stack won't be changed. So if you take Quagga, for instance, for which, by the way, 6Win is also a contributor, it uses a TCP stack, and we do what has to be done, in fact, to synchronize Quagga with the Linux stack that is updated by Quagga with our stuff. So what we call synchronize with Linux. There is a light somewhere, no? 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 Okay. So VPP and OVS DPDK have a different approach. They are separate from Linux, so they are a standalone stack in a certain way, and then they need their own control plane, in fact, to work. So today, if I find VPP, the major way to major control plane are Honeycomb, Yarn, ODL. Of course, OpenStack is going to come and so on. So just to mention with DPDK, so there are absolutely no problem regarding this. You have just to do it yourself, and so good luck. Okay. If we summarize, in fact, the requirement from what we think is a good NFV infrastructure software platform, so if we have to summarize three main items. So of course, performance, which is the very beginning. Secondly, the rich networking feature set. So we don't think that switching is enough, and easy to integrate in the system. So we have the basic features, so Linux Bridge, OVS, VXLAN, distributed routing, firewall NAT, and then in a second step IPsec. And probably in the future, there will be some requirements with a TCP proxy, for instance, that is already under consideration at VHC, for instance. Then we have to integrate this NFVI acceleration with the leading hypervisors on OpenStack to make it work. And then we have also to simply integrate the virtual networking function on top of this, because if we have to recompile and change the VNFs on top of that, it could be a problem. So if we try to, again, to have a snapshot of the different functions we have available, so OVS DPDK is more focused on switching. So VPP, I would say, is Go switching plus routing, and is about to release new capabilities in terms of IPsec, TCP proxy, and 6-WIN-gate, I would say, would be here. Okay. Let us see how we can use this fantastic technology to build real use cases. So I've selected, in fact, how to have a scalable IPsec aggregation solution based on the virtualized servers, and to show how we can achieve this number and what we can save in terms of OPEX and CAPEX. So we have basically here quite simple architecture. So you have remote users, I would say, generally a large number, several thousands. I want to access, for instance, a private cloud in an enterprise through an IPsec aggregator. So the question is how we will be able to manage a pretty large amount of traffic, several tens of gigs, to access to this private private cloud. So let's see how we can do it. So let's take a server first, which is pretty useful, by the way. And then so we can implement the function, the application, the IPsec application in bare metal to start with. So what we need is a DPDK-based solution. We need a high-performance data plane stack, IPsec, here installed in bare metal. And we need to put on top of it a mechanism to build the security association and so on. So there is a famous open source project, which is IT, which could be very nice to be used. And to do that, it would be nice to have it synchronized with Linux, because doing that, the integration between IT and the accelerated data plane will be straightforward. So we can implement this in a virtual machine, and in that case, it will become on a VM. So the difference will be that the driver, the DPDK driver, will be a virtual driver instead of physical driver. And then, of course, we can add other application. At the switch level, so we need a DPDK-based, so physical NIC solution, dedicated high-performance data plane stack, so at least OVS, maybe more, but at least this kind of features, synchronized with Linux, for instance, to instantiate this with OpenStack, which would be great. Okay, so let's see which kind of performance and which kind of saving costs we can have. So here, this is the box. So let's take, we selected 5K IPsec tunnels and encrypted traffic total 10 gig. So let's first use Linux. So we use Linux at the OVS, at the hypervisor, and we use a standard IPsec stack. So here's the limitation of performance. We'll start at the application level. So roughly, here we use, I forgot to say, we use a server, I think it's a Dell one, 12 cores, very standard. So no big machine or whatever. It's a standard, one processor, 12 cores, so standard frequency, so nothing, so you can buy it very easily. So here we have, with all the cores, we have a total traffic of 2 gig, which is 500K per user, which is obviously far from our requirements. Now we keep the virtual switch Linux, and we instantiate a DPDK-based IPsec software gateway. So here the performance is going to grow at 6 gig with no spare core, so it's better, obviously, 3 times if I make the right calculation. But now the limitation is at the hypervisor level. And of course, so the next step is to do both. And here we are able to achieve the 10 gig So 2 megabits per user, and with only 4 cores. So we have only 1/3 of our servers that is used. So the benefit is used to manage the 10 gig by wire speed. So of course, to use this technology, we can use whatever DPDK stack. So it can be VPP, it can be OVS DPDK, it can be 6-win gate. The saving cost. So the ownership costs are drastically lower. So when I say drastically, compare an existing equipment, IPsec gateway equipment available on the market with a server plus a certain amount of price for the software, because software company needs to live also. So the reduction is between, it depends on the traffic, the reduction is between 60 to 80%. So it means that the equipment costs 20 to 40% of the cost of the hardware equipment, thanks to this, the capability to achieve high performance. So of course, it's a first very interesting cost saving. But you can do more, because here, if you remember, I said that we have 8 cores, spared 8 cores. So it means that of course, we should use them. And for instance, we can either serve more users with more bandwidth, or to integrate IPsec with added value services on the same server. For instance, with a load balancer and with other features. So these features that were before implemented in different equipment. So the cost saving are massive. And so it's always interesting. So of course, VPP is a very nice technology, high performance and so on. But what I want to show you is how this technology can be first used to enable the transformation of the networking architecture to virtualization, and second, to enable massive cost savings, okay? So as a summary, so now I think and that's the reason why 6-win is in this business. So why did we join the FIDO project? Because we have a solution available internally. I think first of all, it's a very significant move to see players like Cisco, which is the most important player in the networking space, to move and to open source an internal data plane technology. So that's a significant change in the industry. Clearly, as an expert in this domain, so we have been contacted by Cisco to check if we would be okay to join the open source project, and we say yes, because the market is very diverse. We know that there are today some customers that say, okay, we want to have VPP because Cisco is a major provider. We know also that's the industry, that some players will say, no, we don't want Cisco at all. So there's a need, in fact, for companies that bring the expertise to make possible to provide the solution to the customer. So now we have the capability to do bare metal with DPDK-based solution, to do virtualized solution with DPDK-based virtual switch, and in both we can use different open source technology, DPDK of course, 6-win gate, VPP, Linux, strong SWAN, OpenStack. So now we start really to have a complete set of open source projects to build this kind of application, and that's why 6-win wanted to be part of it. And clearly, our goal is first to support commercial distribution of VPP and to contribute to the project.